All right, I just wanted to take a moment and explain to you how to get started with these three polar equations. That is actually the first thing to notice, that I'm having you graph three equations, and they're a little more complicated than the simple ones that we did yesterday. And so you can discover these equations and their graphs. We're going to ask you to graph them by hand. If you look at the polar graph paper I gave you, it's got a lot of lines on it, doesn't it? But if we just spend a few moments thinking about what each of these lines would represent, you'll find that you've got yourself a really nice resource for plotting points with a lot of precision. Let's look at the angles. They're pretty easy because, well, they're labeled. So we can see here that every one of these dark lines represents 10 degrees. That's perfect because we're going to be plotting points that go by 10 degrees. It's usually the circles that kind of get kids spinning in circles. Well, first off, the darker circles, those represent a full radii. So that one that I just traced there, that would be your first radii of 1. That would make this one a radii of 2. The next one would be 3, 4, 5, 6, 7, 8, 9, 10. If you count carefully, you get 10 full radii. Now, the reason I keep saying full radii is because, well, we've got all these circles in between. So that would make those, that's right, that would make those decimals of a circle, a fraction of a full circle. Let's go to the very center. First of all, we have to understand that that is definitely 0 radii. But my first circle here from the center, you see that would be 0.2. That'd be 0.2, which would make my next circle 0.4. Next one is 0.6, and then we would have 0.8, which takes us then to our first full circle of 1. Now, if you keep counting this way, you would have 1.2, 1.4, 1.6, 1.8, 2 full circles. So every one of these thin circles is another 0.2. All right, now we're going to keep that in mind when we're ready to start graphing some of these points. So how do we do this? Well, mainly on your calculator, you're going to do a little input-output and just make sure that your input-output correctly. It looks like that we can plug in 0 degrees, and get 5. We can plug in 10 degrees and we can get 4.3. You can plug in 20 degrees and get 2.5. And then when you plug in 30 degrees, that actually comes out to be 0. And so fill those into your chart. And what I want to do is make sure that you can graph the first 6 or 7 points here correctly. And just to make sure that we're on the same page, I'm going to be graphing these points. If you continue to plug in, which you should be doing on your own, you'll notice that you actually end up with the negative of these values. Are you ready? We're going to graph these 6 points, these 7 points on our polar graph paper. So we'll start by rotating 0 degrees and counting out 5 radii. So that'd be 1, 2, 3, 4, 5. And we get ourselves our first point, which would be at 5, 0. Now, you don't need to label the points. I'm just writing that down so you understand that that purple point right there is 5, 0. How about 4.33, 10? Well, we'll continue to rotate. We'll rotate 10 degrees. This time we'll count out 4.3 radii. Now, to count 4.3 radii, I would have to go 4.2 and then a little more. And I get myself to my next polar point. How about 2.5, 20? Keep rotating 20 degrees, but this time count out 1, 2.5 radii. Probably pretty close to that point. And finally, at least for now, we have 0, 30. Now, I technically would rotate 30, but since I'm counting out 0 radii, pretty much just plot a point right there in the middle. Now, when you're plotting these points, you're technically graphing an equation. So really what we're trying to do is graph a line.
What line? Well, it would be the line that connects these points in the order that you graph them. And the rule of thumb is that you want it to be kind of like a smooth line, not necessarily like straight, jagged lines. So some students will plot or will connect their dots as they go. If you don't, just make sure you keep track of the order that your points are in. And at some point, you want to get that pencil drawing, again, a smooth line. It's the negatives that get a little tricky. So let's make sure that you get the idea. I'm going to plot the point -2.5, 40, which does mean I'm going to rotate to 40. But really, since it's a -2.5, I'm going to then go backwards. I'm going to go on the opposite side, which ends up being this line. A straight edge works wonders here, holding a straight edge up to your paper. So I really want to count out 2.5 radii, and that would put me at that point. How about the next one, which is at -4.3, 50. Well, of course, I want to rotate 50, but since I'm on the opposite side, I'm going to actually count out 4.3 radii, which would get me pretty close to there. And then at least for now, my last point, which is at -5, it's actually -5, 60. Well, I'm going to rotate 60, but I'm going to end up on the opposite side of 60, which is this line. And of course, I'm going to count out 5 radii, which will put us right there. What kind of line are we drawing here? Well, again, it's a line that connects these points in the order that I graph them. It's a nice smooth line. And as you can see, when I drew it this time, I went right on through the middle, back to the opposite side. And, well, I'll tell you that what you're starting to create is a shape that has petals.
You continue. You want to fill out the rest of the table, both sides. You want to rotate the whole way to 360 and plot your points. All right, now we've got 3 polar equations to make 3 polar graphs, and I'm going to give you a double homework check on that next time we're together.